Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to the basic introductory concepts related to mechanics. So far we have discussed the the introductory concepts related to it, the categorization, then the concept of rest and motion, which is very important to understand. So in this video we are going to discuss about the various parameters that are involved when we use the concept of rest and motion. What are the various parameters that we require to quantify it, to express it in terms of a number, a numerical value. Okay, so basically that. So the various parameters that are required, the various concepts that we need to understand before we study motion, rest and motion. When we say motion, rest is already it means that we'll discuss rest, because it is from rest that we start things and then we describe motion. So the various parameters that we need to understand are distance, displacement, speed, velocity, acceleration. Okay, so first let us discuss distance and displacement. Okay, let us try to understand these two things. Okay, let us say we have 2 points. Okay, let's say this is point A, and let us say this is point B. Okay, now how many number of ways do you think we can reach from point A to point B? In how many ways? Let us see. This is one way, like this. This is another way. Then let's say this is another way, like this. This is another way. Then this is another way. This is another way. Okay, like this. Let's put arrowheads to understand. Okay, these are the different ways we can reach, but we have here ignored one clear-cut, straightforward thing, straightforward path, which is the straight path from, okay, it is not straight, slightly bent. My drawing skills are not that great, but this path, this straight line path in red. Here all these curved paths here and there through which we can reach A to B, which are drawn in blue, they are all distance from A to B in blue. Okay, the blue ones are distance from A to B. The one path straightforward, straight from A to B, the straight path from A to B, that is displacement. Okay, that is displacement. So The blue ones are distance, and the red one, the only red one, straight, is the displacement. So the basic difference between distance and displacement is, distance is the total length of the path travelled by an object during a given time. Displacement is the shortest distance, straightforward distance from the initial position, in this case A, to the final position B. So basic difference between distance and displacement is, distance is a scalar quantity, which means it has only magnitude, no direction. Okay, only magnitude. Whereas displacement is a vector quantity. Okay, and has both magnitude and direction. Here there can be infinite possible ways by which we can cover or reach from A to B, different ways. Okay, they are all distance, but only one shortest path, straightforward path from A to B, that is displacement. This is the fundamental difference between distance and displacement, but both distance and displacement, they are expressed in the same unit of lengths, be it meter, kilometers, centimeter. Well, centimeter distance displacement, okay, let us also consider that. So they are expressed in the same way. So let us try to understand the concept of distance and displacement through an example. Suppose you have your house here somewhere. Okay, we will consider that as the reference. Okay, this. From there you started and you traveled certain distance like this. You went to a coffee shop, okay, which is the total distance which you have covered is, let's say, 10 kilometers. Then you went like this, traveled 5 kilometers to a bookstore, okay, and then you came back to your house. Let's say this distance is, you didn't take the same route, you took a different route because of traffic and all that, and you covered another, let's say this is 15 kilometers, okay, this. So now here, if I say to you that you have covered a lot of distance, okay, you have covered a lot of distance, but the net displacement which you have achieved is 0. Displacement is 0, but distance that you have covered is 10 plus 15 plus 15, which is equal to 30 kilometers. Okay, 30 kilometers. So here, if I would say that what is the displacement from your house to this coffee shop, so we will connect these 2 points, okay, these 2 locations by a straight line, okay, not a curved one, perfectly straight line, okay, a perfectly straight line. And let's say the length of this line, okay, the length of this line is, let's say, 8 kilometers or 7 kilometers, then that will be the displacement and the direction will be northeast, okay, direction will be northeast. Similarly, if I say what is the displacement from here to this bookshop, let's say. So for that what we'll do, we'll connect these two locations by a straight line, okay, by a straight line. Let's say this distance is, this length of this straight line is 12 kilometer. So you will say that the displacement is 12 kilometer and it is southeast, okay, it is southeast, little bit southeast, just southeast, just towards the southeast direction, okay. So these are the concepts related to distance and displacement. These red lines are displacement, the shortest path, the shortest distance connecting the initial and final points, a straightforward path. This is displacement. But these black curved lines, curved paths are all distance. They are distance. They are all distance. This is distance, this is distance, this is distance. And here when you finally reach the house, the net displacement is 0. Okay. So it is somewhere here, the bookshop, the coffee shop is somewhere here, okay, with respect to the house. So this is how we will say it, okay, the reference, okay, the distance and displacement, the basic difference between the two. So we have covered distance and displacement. Now speed and velocity. Okay, so we have covered distance and displacement. So speed and velocity are two such parameters that are involved with respect to these two things which we have discussed. So here, wherever we have distance, there the concept of speed will come into play, okay, and wherever we have displacement, there velocity will come into play. So this one here, speed, is a scalar quantity. This one here, velocity, is a vector quantity. Here it has only magnitude but no direction. Here it has both magnitude and direction. So now let us see what speed and speed and velocity is. Speed of a moving object here is defined or is expressed as the total distance covered divided by the total time taken to cover the distance. So here please pay attention to this distance, not displacement. Total distance covered in a given period of time. Okay, so here, as I said, as distance is a scalar quantity, speed, which is derived from displacement, speed which is derived from distance by time, it is also a scalar quantity. It has magnitude but no direction. Speed of an object can be positive or 0 but not negative. Here is an important point again. As we know, displacement is a vector quantity. So a vector, we have the concept of negative vector, a vector drawn in the opposite direction. Okay, so we have discussed it in basic concepts of vectors. Let us say we have a vector like this, okay. Then we can have a vector which is drawn in the opposite direction as this minus v vector. As displacement is a vector, it can have negative values, but distance can never be negative, okay, because it is a scalar quantity, not a vector quantity. Okay, so speed is total distance divided by time. The SI unit of speed is meter per second, but sometimes for convenience it is expressed in kilometers per hour. Then the concept of uniform speed, variable speed and average speed. Okay, uniform speed. Let us say we have an object, let's say anything, a vehicle or anything. It covers distance, and we keep a track of how much distance it covers in equal intervals of time. At specific time slots, we take readings of the distance. Let's say in the first, we divide it into equal time slots of 2 hours. Let's say in the first 2 hours it covers a distance of, let's say, 4 kilometers. Okay, then this is the first reading. Then in the next 2 hours, that is from 2 to 4 hours, okay, the gap is 4 minus 2 hours, the distance is, let's say, 8 kilometers. This is the second reading. Then we have the third reading that we have taken. It is at 6 hours, again 2 hour gap. The distance is, let's say, 12 kilometers. So if you see, this is the third reading, and likewise, okay, this. So here in this first time slot, the speed is distance by time 4 by 2, which is 2 kilometer per hour. In the second time slot, it is speed is distance by time, which is 8 kilometers by 4 hour, which is again 2 kilometer per hour. Again, in the third time slot, it is the total distance that it has covered is 12 kilometer, time is 6 hour, again 2 kilometer per hour. This. So it is traveling at an uniform speed, which means it covers equal distances in equal intervals of time. Okay, this. Likewise, if we have another situation where we take the same time slot, that is time interval of 2 hours, but here in this case, in the first time slot, it covers, okay, 2 hours, first 2 hours, d1 is, let's say, 4 kilometer. Then in the second time slot, again after 2 hours, it is 4 hours, the distance is, let's say, 7 kilometer. Here this is 2, okay, d2 not d3. d3 at 6 hours, let's say it covers 10 kilometer, like this. So in the first time 2 hour interval, the speed is 2 kilometer per hour, 4 by 2. Here it is 7 by 4 kilometer per hour, okay, and here it is 10 by 6 kilometer per hour. So here the speed is changing, it is not covering equal distances in equal intervals of time, it is covering unequal distances in equal intervals of time. Okay, so this is variable speed or non-uniform. This is uniform speed. This is variable speed. This. Okay, so an object is said to be traveling with variable speed if it covers unequal distances in equal intervals of time. Okay, and then we have the concept of average speed. Average speed basically the finally how much at last when the object stops at the destination, the final point, total distance covered, what is the total distance that the object has covered, and finally how much total time taken. Okay, that is the average speed. We can cover, okay, a journey of a vehicle from one point to other, like we have discussed, from one point to other. Let's say it covers a certain path like this. Okay, this is the initial point, this is the final point. The entire journey can be broken into some time slots, equal time slots, okay, where readings are taken. We will cover it in equal time slots. Okay, from this here. And for each time slot, equal time slot, we determine the distance covered in those time slots. The average speed is basically the total distance covered in those time slots divided by the total time taken, which is basically here T1 is equal to T2 is equal to T3, equal time slots, total distance by total time. Okay, that is the average speed. And there is another concept which is the instantaneous speed, which is here whatever we are getting, the value of speed, uniform, non-uniform, average, it is, let's say, final. When it reaches the final point, the average speed throughout the journey is this. But let's say we want to find out at a specific time instant, let's say at this point when the vehicle was here, okay, at this point, let's say the time was some instantaneous point t dash. What was the velocity, what was the speed here at this point? So that speed at a specific point, at a specific instant, that is called as instantaneous speed. Okay, this speed is given to us by the speedometer of the vehicle, which gives us at a particular point of time, at a specific instant, at that moment, how fast the vehicle is going. That is instantaneous speed. Okay, so this is the various things that are related to speed, which involves distance and time. Next is velocity. Same thing as we have discussed with speed, same expressions, but you have to make one substitution. You just have to replace distance with displacement. Everything stays the same, all the definitions are the same, but here we are concerned with displacement. Distance is related to speed, displacement is related to velocity, because these are vector quantities. These are scalar quantities, only magnitude, no direction. Okay, so displacement comes into play here. So the velocity of an object is defined as the total displacement, net displacement, divided by the time taken for that displacement to take place. Okay, so here let's say displacement, if you want to express it, let us say we have an object which starts at point O, it travels in the positive x direction towards the right, and here it covers certain displacements. Okay, here this one, this one, this one, like this. Here let's say it is 2 kilometers, here it is 4 kilometer, it is 6 kilometer. Here the time is this 2 hour, here it is 4 hours, here it is 6 hours. Okay, equal time slots. Okay, 2-hour time slots. So in the first 2 hour, displacement is 2 kilometer, velocity during this interval is 1 kilometer per hour. Displacement by time, 2 kilometer by 2 hour. Here also in the second time slot, this is first, this is second, this is third. Here it is again 4 by 4, total displacement 4 by total time 4, it is 1 kilometer per hour. Again here it is 6 kilometer by 6 hours, 6 by 6, again 1 kilometer per hour. So here the velocity of the object, it remains constant, uniform, okay, constant. So we say that this object is traveling with uniform velocity, and at last net displacement by total time, that is total displacement is 6 kilometers, total time is 6 hours, so 1 kilometer per hour, that is the average velocity for the entire journey. Now if you want to calculate, let's say for this interval from time instant 1 to 2, what is the velocity? In that case you have to do the displacement for time instant 2, which is this position as the object travelled from this point to this point. For this interval from 1 to 2, this is the initial position, this is the final position, only for this interval from 1 to 2. So here final position S2 minus initial position S1 divided by T2 minus T1. Here it is 4 minus 2, 4 kilometer minus 2 kilometer by 4 hour minus 2 hour, which is again 2 by 2, which is equal to 1 kilometer per hour. So the velocity during this interval is also 1 kilometer per hour. Okay, so this is the concept of velocity. So if we try to plot this, okay, so here it is 2, 4, 6. If we try to draw this, okay, which is this is the time axis, let's say the x-axis, and this is the displacement s. So we have 2, 4, 6, 8. Here also say 2, 4, 6. So here it will be this at distance 2, or for time 2 hours, distance is 2 kilometers. This is in kilometers, this is in hour. At 4 hour point, this is 4 kilometers. At 6, it is this. So this displacement time graph, it will be a straight line with a certain slope, and this slope of the line, it gives us the velocity, which is the slope of the displacement time graph. So if we want to calculate the velocity between any two points, okay, let's say this point and this point, okay, in that case what we have to do, we have to determine the displacement for this time duration, okay, delta s, and the time interval, the time gap for these two duration, okay. This is the thing. So here it is, if we try to calculate it at 4, it is 4, at 2 it is 2, same thing, delta s by delta t is equal to how much? Final minus initial, that is 4 minus 2 by 4 minus 2, which is equal to by 2, 1 kilometer per hour. This we have described it here in a numerical manner. This is done here graphically from the graph, which is basically the slope of this. The slope here is constant everywhere, okay, the slope is constant everywhere. At any point the slope is constant because this is uniform velocity. It means the velocity at each instant of time is constant, okay, it is constant. So we have discussed uniform velocity. Now we will discuss non-uniform velocity. Same thing. Let's say we have another point. Okay, we have another starting position, let's say O, and we are covering, that object is covering, moving only along x-axis because it is displacement. Again, in the first 2 hours, let's say it covers 1 kilometer. Okay, let's say it is 2 kilometers. In the next time slot, it covers 1 kilometer. Okay, so it's 3 kilometers. Then the next time slot, it covers 4 kilometers. That finally it is 7 kilometer. Okay, so here it is 2 kilometer. Here it is 2 kilometer in the first time slot, 2 hours, distance is 2 kilometer. Then in the second time slot, 2 hour time slot, distance covered is how much? 3 minus 2. Okay, let's say it is covered, the total distance which is covered at that point is 3 kilometer. Then again, this is 4 hours. And here at 6 hour time, the distance is 7 kilometer. So here the velocity during this interval is 1 kilometer per hour. Here it is this displacement by time, which is 3. The total displacement is 3, the total time is 4, 3 by 4 kilometer per hour. And here at this point, the total displacement is 7 finally, divided by the total time, which is 6 kilometer per hour. At every point the velocity is changing, it is variable. Also the interval speed, if you want to calculate the interval speed for interval 1 to 2, let's say, in between this time interval 1 2, then here for this the velocity is velocity during the interval 1 2, s2 minus s1 by t2 minus t1. S2 is 3 kilometers. Okay, these are not d's but s, okay, not distance, it is displacement. Displacement is expressed in terms in s, okay, not d. Okay, this is s, not d. So here it is 3 minus 2 by T2, which is how much? 4 minus 2, T1 is 2. So it is 1 by 2. Then if we want to calculate for this time interval from 2 to 3, okay, in that case it is S3 minus S2 by T3 minus T2. As the time slots are of equal value, which is 2 hours, the displacement here is 7 minus 3, which is 4 by 2, which is again 2 kilometers per hour. Here it is 1 by 2 kilometer per hour. So again the velocity in specific intervals, that is also changing. So here if we plot this graph, okay, the displacement time graph for this equal time slots 2, 4, 6, okay, 2, 4, 6 like this. Here it is the values are 2, 3 and 7. Okay, here let us say it is 1, 2, 3, 4, 5, 6, 7 like that. So here it is at 2, it is 2 kilometers at 2 hours, then at 4 it is 3, then at 6 it is 7. Let us say it is somewhere here. So if we join these points, it is not uniform, it is not a straight line, and here the slope of this line at each particular interval, let us say, it is changing. Here the slope is something theta 1, let us say, here the slope is something theta 2 here, here also the slope is something else, it is changing. Slope is changing means velocity is also changing. So we will discuss in detail related to the graphical analysis of various things in detail. So this is non-uniform velocity, okay, non-uniform velocity. So we have covered uniform velocity if it covers equal distances, displacements in equal intervals of time. This is uniform velocity, which means magnitude as well as direction of velocity remains constant. Then average velocity is the total displacement. Finally, when it reaches the final destination, the total displacement from the initial to the final position, like in this case when it reaches from A to B through the straight line path, the net displacement, the shortest path, straightforward path from A to B, divided by the total time taken for that displacement, that is the average velocity. And variable velocity, when it covers unequal distances in equal intervals of time. In equal time slots, it covers unequal displacements, it has unequal displacements. Another interesting case of variable velocity is circular motion, okay, circular motion. When an object, it has circular motion, in this case at each point the direction of the velocity is changing, which is basically tangent to this circular path. So here also it has variable velocity, even though the magnitude stays the same, even if the magnitude of the velocity is same, but it will be considered different because the direction is changing. Even if the magnitude stays same, nothing, the direction is changing, so it will be considered variable velocity. At each point the direction is changing. So it is an important, circular motion is an important case of variable velocity. So we have covered velocity, and then another thing, instantaneous velocity, same as instantaneous speed at a specific instant of time. Okay, here at a specific instant of time, any point on this curve, specific point on this curve, be it anything, anywhere, the velocity at this point, particular point, anywhere on the curve, that is called as instantaneous velocity. Not in particular interval, within a particular interval or the average one, at specific time instant, at a particular time. What is the velocity? That is instantaneous velocity. For that we use the concept of limits and calculus to determine instantaneous velocity, which we'll discuss in the next video, where we'll discuss the graphical analysis of motion. Okay, there I will discuss it. So the next concept here is acceleration. Okay, so here acceleration, that involves velocity. Okay, acceleration involves velocity. Again, as velocity is a vector quantity which has both magnitude and direction, acceleration too is a vector quantity. It has both magnitude and direction. So if we want to understand acceleration, let's say we again take time slots. Okay, time slots, equal time slots, let's say t1, t2, t3, like that, and we take readings of velocity at these specific time slots, these points. Let's say at the first time slot, let's say we take again equal time intervals. This is 2 hours, this is 4 hours, this is 6 hours. Let's say the velocity here was 4 kilometer per hour. Okay, here let's say it was 8 kilometer per hour, and here let's say it was 12 kilometer per hour. So acceleration basically is the change in velocity. Okay, the change in velocity from one instant of time to another, divided by the time taken for that change of velocity. Here starting point is t0, this is 0 hour. So here in this time slot from 0 to 1, okay, this is 0, this is 1, this is 2, this is 3. For this time slot from 0 to 1, the change in velocity is 4 kilometer per hour, and the time taken is from 0 to 2 hours. So it will be 2 kilometer per hour square. Okay, basically we express it in meter per second. So let's use seconds and meters here. So this is in place of kilometer per hour, you can say meter per second, but anyway it is this distance per time square. This is the unit of acceleration. Whether you use kilometers or meters or seconds or hours, it doesn't matter. Again, for this time slot here from 1 to 2, the change in velocity is 8 minus 4, again 4 kilometer per hour, that is the change in velocity. Okay, 8 minus 4 divided by the time which is taken, 4 minus 2, 2 hours. Again it is 2 kilometer per hour square. Again for the time slot from 2 to 3, the change in velocity is 12 minus 8, final minus initial. 12 minus 8, that is 4 kilometer per hour, time is 2 hour. Again 2 kilometer per hour square. So basically if you want to write acceleration, it is final velocity minus initial velocity by final time minus initial time. Here for this time interval from 0 to 1, acceleration from 0 to 1, it is v1 minus v0 by t1 minus t0. Basically it is 4 minus 0 by 2 minus 0, which we got this result here. Similarly here for this acceleration during the time interval from 1 to 2, it is velocity at point 2 minus velocity at point 1 by t2 minus t1, which is 8 minus 4 by 4 minus 2, which is 4 by 2, which is 2 km per hour square. So this is the same thing as 3. Acceleration from 2 to 3, it is v3 minus v2 by t3 minus t2, which is 12 km per hour by 8 minus 8 km per hour divided by 6 minus 4, which is t3 minus t2. Again it is 4 by 2, which is 2 km per hour square. So here if you see, acceleration at every point is constant. a01 equals to a12 equals to a23. For the entire duration, acceleration is constant. So this is the case of uniform acceleration. This is uniform acceleration. Okay, which means acceleration is constant. Okay, acceleration is constant. So if we try to plot this, okay, it will be, let's say 2, 4, 6. This is the time in hours, and here it is velocity in kilometers per hour, and here it is 4, 8, and let's say here it is 12. Here one reading, that point, here one, here one. So this one, uniform acceleration, is a straight line passing through the origin, where similar to uniform velocity, the slope at every point is constant. This is uniform acceleration. But if the acceleration, okay, is different at different time slots, let's say here it would have been 2, here it would have been, let's say 5, here it would have been 15 or 16. In that case, for equal time slots, the rate of change of velocity is different in different time intervals. In that case, the curve would have been somewhat different, like this, you know. In that case, for non-uniform acceleration, it would have been like this, different, where the slope at different points is different. Okay, so that is the case of non-uniform acceleration, which we'll discuss in detail in the next video, where we'll discuss the graphical analysis of different parameters. So here also the same concepts related to as acceleration is a vector quantity, the direction of acceleration is the same as that of velocity. Acceleration is positive, it means velocity is increasing, and negative if velocity decreases between two time slots. Negative acceleration is retardation. So here what I'm trying to say, let's say at one point the velocity was, let's say in meter per second, it was 4 meter per second at 2 seconds. And here the next reading, the velocity was 2 meter per second at 4 seconds. So in this case, acceleration between these 2 points, 1 and 2, is final velocity, which is 2, minus initial velocity, which is 4, divided by 4 minus 2, which is equal to minus 2 by 2 equal to minus 1 meter per second square. It is negative acceleration or retardation because velocity is decreasing. This is negative acceleration or retardation or deceleration. It is also called as deceleration. Then we have the same concepts, variable acceleration if the velocity changes by unequal amounts between equal time slots, and if direction also changes, we say that acceleration is variable. And then average acceleration is basically the total change in velocity when from the initial to final point, from the initial to the final point, the total change in velocity from first to last point, final velocity minus initial velocity divided by the total time taken to from the initial point, starting point to the end point. Same as average velocity, expression is the same, but the the meaning is different. Here it is change in velocity, the total change in velocity throughout from initial to final point, that is Vf minus Vi by Tf minus Ti, that is the average acceleration. Okay, so here we have discussed the various parameters required to describe motion of an object. Here we have discussed them theoretically and given the mathematical expressions. In the next video, we will discuss the graphical analysis of these parameters. Okay.